Okay, students, welcome back. This is Mr. Morris. This is also for the benefit of some online classes I'm teaching. I'm going to show you how to do a stress analysis with a 3D model of a couple of parts. And then for my 3D printing class, I want you to have an understanding that sometimes things are machined, sometimes things are 3D printed. Is the machine part stronger? Probably so than the 3D printed part, but is the 3D printed part satisfactory for your application? Perhaps you don't have to machine it. You see what I'm saying? You might not have to machine it. You can 3D print instead. And yes, you can 3D print metal. So you know you can 3D print metal, right? Is everybody aware of that in here? You can 3D print. I thought that was my glasses for a minute. All right, I'm gonna share my screen, and so I guess it's a good thing to do this because it's a new updated video and the latest Inventor software. So if you're doing this with me, I'm gonna go fairly slow, but if you just want to watch, please just feel free to do that. I'm gonna go to new, okay, and I'm gonna go to English and standard IPT and create. Everyone, most of y'all in the class can teach that part, right? So y'all got that down to a science. It's taking its time down here in the lower left-hand corner. You can see that it's still loading. This computer is slower than Mr. Morris walking. All right, there we go. I think. Okay, here we go. All right, so it's finally up, and I'm gonna go to Start 2D Sketch, Start 2D Sketch, and I'm gonna click on the XY plane. That's the one that I choose 99.9% of the time. But you can choose whatever plane you wish, because you know with the view cube up here, you can, for all intents and purposes, you can rotate whatever angle you wish. I'm gonna go to circle, circle center point, and I'm going to go to my origin. You see it's going to snap to the origin. It's going to be green. Click it, drag it out. Now, I did this once yesterday for my engineering students. I think I used 4 for the diameter of the shaft. Enter, and I did a right click. Okay. All right. Now you know how to rotate your scroll wheel, zoom in and out, hold down your scroll wheel to pan. We're going to finish the sketch. Oops, let me move that out of the way. I'm going to finish the sketch, and I'm going to go to extrude. And I'm going to make this, I don't know, about 6 inches. About 6 inches long. Select OK. All right, now I want to go to Start 2D Sketch, Start 2D Sketch, and I'm going to click on this end of the shaft. And I'm going to, again, draw another circle at the center. This is a step shaft. The reason I'm drawing a step shaft, because you can see the greatest stress concentration. That's where the shaft is its weakest point. And you'll see that when we do the analysis. All right. So I'm going to make this 2 inches. Okay. And then I'm going to finish the sketch, and I'm going to extrude this. And again, I'm going to leave it 6 inches. That's a nice, convenient. All right, now, for my students here who are going to be engineers one day, and probably most of y'all will end up being an engineer at some point after it's all said and done. You notice how we have a sharp corner here? It's a sharp 90. You see that? As a designer, you don't really want to have a sharp 90 sometimes like that, because it makes it weaker. It's not as strong. So one way you can fix that is you can use a fillet. Just come and use a fillet. right? And I'm gonna click right here, and y'all have used this before. And I'm gonna select OK. All right, now I'm gonna point out something to you. Why is this stronger than the previous design? Well, look, you've actually got extra material. Look, you come down here. This is what you had before, right? So now you have this little bit of extra material. You see that? And it makes it stronger. So a lot of times it's in your best interest to not have but sometimes you have to have a sharp corner, but not always. If you don't have to have a sharp corner, this is probably a better design. All right. Now, so we have this part, a very simple step shaft. I'm gonna file, and we have to save as. And again, you can just call it stepped shaft if you want to. Stepped shaft. Okay. And I'm going to select save over here. All right. Now this is our part. Sorry, I was kind of favoring this isometric view for some reason. You can't do a stress analysis on a part unless you define the material that the part is made of. So in this case, if you were using ABS plastic on a 3D printer, you would select a plastic, ABS plastic, for example. But I'm just going to make mine. Let's say I have a 3D printer or something here that prints metal. I'm going to right click on this, and I'm going to come down to iProperties, and I think all you guys are experts at this now. You can come in here and I'm going to select steel alloy. You can select whatever material you wish. I don't know if you've ever noticed that you get a lot of the mass and area volume properties here. That's also the center of gravity for that part. Okay. And I'm going to apply this and close. Okay. Nothing new here. You've seen all this before, and that's great. Now that I have the material defined, I want to do a stress analysis on it. Okay. So I'm going to come up here to, this is new. So you might want to take some cheat notes or whatever, or shorthand notes. Go to environments. When you go to environments, over to the far left, you'll see something called stress analysis. Click on stress analysis. And then select right here to the left, you're doing a study. Now, for right now, this panel is more involved beyond the scope of this class, but we are doing a static analysis here. So everything is fine for right now. Basically, just check off static analysis and select OK. So basically, you're accepting the defaults here. All right, now I'm going to do a couple of things with this shaft. The first thing I'm going to do is I'm going to do a tensile test, which means you're pulling on it. You're pulling on the part, okay? And in order to do this, I have to fix this end. So there is an icon here called fixed. You're constraining it, right? So click on fixed. And if you click here it looks like a little Band-Aid. Okay, it looks like a little Band-Aid. What that means is that might be welded to a bulkhead. It could be firmly secured where that's not the weakest point, right? It's welded or it's secure where it cannot move at all. All right, I'm going to select apply. And I'm going to close this out. So there's the little bit. This is fixed. Now, I want to come in here and I want to apply a mesh view. Now, this would be like if you ever take a class called finite element analysis, you have to break up your part into individual finite elements. Okay. Which is the grid here? You see a grid? All right. Now, I want to apply a force here at this end. I'm going to do it tensile force first, which is you're pulling. So I'm gonna go to force. I'm gonna click right here. All right, now you see the arrow right now is pushing on the part rather than pulling. I'm gonna flip the direction, and I'm gonna put on here a force of maybe 1,000 pounds. So y'all have taken statics, right? Most of y'all have taken statics in here at some point. Okay. So you understand the meaning of stress. I'm kind of stressed today, but not mathematically stressed. Apply and select this. All right. So here you go. Here's the mesh view again. Here's the force. Now we can do a simulation here. Run. All right. I want to show you something. This is called the von Mises stress. For right now, I just want you to look at the color code. The red is the greatest stress that the part's going to see, right? That's the greatest stress that the part is going to see. And, it's not too terribly bad. Okay, so it's 0.6132 KSI. So you have to multiply this by 1,000. All right, so 613 PSI. But now you can do an animation of this. You click on animate, and you can record it as well if you wanted to record your animation. Click here. Select OK. I need to do it. Hang on just 1 second. That's it. So it's pulling it, right? It's pulling it. So if you haven't seen this before, this is a very good tool to do some sort of stress analysis on a part. Okay. Now, the beauty here is, Mr. Alfredo, you're famous now because your name mentioned in the video, right? If I wanted to create a report here of what I just did, if I come up here to report and say, okay, it's generating this nice report that I can submit. You can even put it into a PowerPoint. You can create a PowerPoint and clip all these images, right? And put it in there, okay? It's a slow computer, but all right, come on, almost there. All right, look here. You can scroll through this. It gives you all the information about your part. Isn't that cool? Back up here, it gave you what? The designer, the date, material, density, mass, area, volume, the element size of the mesh, material designation and its properties, Young's modulus of elasticity. You have all these pictures that you can cut and paste. Look, all right, here's all your stresses. Again, this is more for a higher level course, but I think you'll have an appreciation for this later. So you can do a stress analysis of a part. All right, I want to show you one more. I'm going to close out this. Oops. Wait a minute. Did I close out my Zoom? Please tell me I didn't do that. All right, I want to stop the share for a minute. Thank goodness I'm still recording. Okay, am I still recording? Yeah, I'm still recording. All right, I'm going to share my screen and go back into Inventor. Sorry about that. All right. All right, so I'm going to finish this analysis. I'm done with this one, right? I would like to do another analysis on this shaft. So I'm gonna come here and go to environments, stress analysis. I do not want to, I want to delete this force. It's gone. The fixed end, I'm going to leave the same here. I'm going to leave the fixed end right here. See that? There's the fixed end. It's still there. Again, we have our file name. All the material properties are in place. This time I'm going to do torque. So I can click on this end, and you can change the direction. So you're applying a torque, a twisting motion, torsion, right, to this part, right? And let's say we want, I don't know, 1,000 inch-pounds here. Okay, so force times the distance, right? Force and the distance here. So that's the moment or the torque here. All right, say okay. I want to turn on the mesh. I'm going to simulate, run. All right, so you see the red again, that's where you see the stress is not like it was earlier. But if you want to do an animation, click on animate. And you can see it's twisting. Okay. I'm going to do one more here, and then I'm going to print out some parts for some 3D printing students. I'm going to close it, finish the analysis. I'm going to go to File, New, English, Standard IPT, Create, Start 2D Sketch, Start 2D Sketch. Click on the XY plane. I'm going to go to Rectangle. I'm gonna make this a 4x4 cross section. Do a right click, okay, scroll out, finish the sketch. Now I want to give it some depth. Extrude. We'll go to other direction. Okay, so nothing new here. You've done this before. Start 2D sketch, start 2D sketch. Click on this face. Sorry, let me do that again. Okay. I really didn't want to do that. I'm gonna delete this sketch, right click, delete. Guess it's not doing what I want. I'm going to delete that work plane as well. All right, start 2D sketch, start 2D, click on this face. That's what I wanted. It probably would have worked fine with a work plane, but I'm going to put a hole through this. And even if you're not an engineering student, I've never been exposed hardly to any of this before, understand that your greatest stress is going to be around where the hole is. That's where the greatest amount of stress would be, is where the hole. We'll make it 1.75. Enter. I'm going to do a right click. Okay. Finish the sketch. Extrude. I'm going to go the other direction. Select OK. I'm going to give this a material designation. Medical. Here's ABS plastic here. It's okay with you. A lot of 3D printers use ABS plastic, so I'll do ABS plastic. Here's all the material properties and geometric properties. Apply, close. Okay, so that's ABS. So we have ABS plastic. We're going to go into environments, stress analysis, create a study, select OK. Now we want to anchor one side of this. I'm going to fix this. Say OK. Now, just for the fun of it, this time we'll put a force here, but we'll leave it as a compression force, if that's okay. Put 1,000 pounds there, apply, close it out. All right, I'm going to turn on the mesh. and I'm going to do a simulate. And you're going to see the red. That's where your greatest amount of stress is. Where the red, that's the greatest stress, right? And then the yellow is the next highest level of stress, and green is getting lower. As you get blue, there's no stress. Okay, no stress with the blue. All right, now I'm going to do an animate here. You see that one? Okay, so that's doing a compression. I could pull it and do a tensile test. All right, I wanted to show you this because I'm pretty sure next semester, in the fall semester, when I take this independent study and computer aided design, it's a 800 level course, Old Dominion. I'm going to be doing some sort of stress analysis with the computer. So select OK here. We're going to stop this. I hope you enjoyed this little introduction. Again, you don't have to do an assignment with this. So that's the good news, right? Stop the share. And for any online folks, have a good day and we'll see you later. So let me stop the recording.